Okay, so I've got out the light ring. We're going to christen this thing. Okay, I'm going to turn it on and... Oh, that's bright! Ah! Hey there, welcome back to the vlog. So today I want to talk about Bluetooth Low Energy 4, or BLE as it's sometimes known. Many people have appliances and other gadgets that use Bluetooth, but very few people actually understand how it works. I just happen to have something that you just saw kicking around that I thought, this would be a really good example to try and work out where Bluetooth fits into this and what it's doing. As you just saw, there's an Anki Overdrive behind me, and whilst I don't want to get too down into the trenches with the technology, I think it's good to go down a certain amount just so you get an understanding of how this technology actually works, because it uses Bluetooth. So the first thing I guess we have to discuss is the track, just so that I can put that aside and say that it's not the track that's really the interesting part here, although the track itself is actually interesting in its own right. So, if you've never seen Anki Overdrive track before, this is what it looks like. Basically, it's a very sort of flexible piece of... It's almost like there's card on one side and there's like a plastic coating on the other side. Underneath this plastic coating, there is basically 16 printed tracks, and these tracks, like the ones that you can see here, that's just for us to see, but what the car sees is actually infrared, so it looks through this black plastic which is infrared transparent, and it can read the barcodes that are on the track underneath. That information then tells the car what type of track piece that it's sitting on, which direction it's going. It can infer by how fast the data is moving underneath it, how fast it's going. It can also work out how far along the piece of track it is, and it can also tell which of the 16 lanes it's in. So whilst as a human we see 4 lanes, because you can race 4 cars simultaneously, under the hood there's actually 16 lanes. It gives it a little bit more granularity when it's changing lanes and so forth. So now that you understand that, yes, the track does have a part to play in this, but this isn't what we're going to go down into today. Okay, so I'm going to put the track away. What is really interesting are the cars, and the cars I'm now going to go into because, this is really where things start to really get interesting. The cars themselves are effectively robots. If you look at what Anki does, the manufacturers of this toy, if you look at what they do, they're actually a robotics company. And so everything is all about the mechanics, the communication, and the interpretation of information that's coming from the outside world, and then how that works with the rest of the outside world around that object. Whether you're looking at the Cosmo, or if you're looking at Vector, or whether you're looking at the Overdrive series of cars, it's all the same thing. It's take input, process it, and have an action come out at the other side of it. So the cars, they're looking about 500 times a second at the track and communicating and everything else. And so you've got a lot going on, but most of what actually goes on happens in here, not inside the cars. So what is happening here and with the cars? That's what we're going to dig down into. So there's this misconception that quite often technology is a lot more complicated than what it really is. Here's a photo of an office in 1903, and that picture has everything to do with this overdrive car, which I just showed you on a track. So of course the question is, where is this sort of connection between the two? If you've ever seen these tubes on the end of the desk here, these are called speaking tubes, and they used to be quite common over 100 years ago, especially in large office buildings or in mansions where people needed to communicate across floors, but they didn't want to shout at each other. So the original idea was that you basically have this tube, and sometimes there's a cone on the end of it, and you shout down it, and somebody at the other end is basically listening to it, And then when they finish listening, they shout into the tube, and of course you're listening at the other end. So this is effectively what happens with Bluetooth. So a couple of things that you need to know beforehand. There are appliances and devices. For instance, here is a Soundcore Bluetooth speaker, and this speaker will have an identifier that tells us this is a speaker and this is what brand and model it is, and it's basically a unique identifier in case we have two speakers that are identical models. So on top of that information, other things that you need to know about is there's something called a service, and this service could be, for instance, there will be a battery service in here that tells me how full is the battery. Doesn't do much else other than that, but there is a service in there for this. And there is another service in here which we can send across sound information to, and it will then play that out of the speakers. Each of those services is also going to have what's called characteristics. For example, I could have a battery service which has a characteristic where it tells me how full that battery is. I also have a characteristic where I send sound data to on that particular service, but I could send other data to that service that might have a different function, right? So now we go back to this car. This car will have a service which is the control service that we speak to, but it will also have characteristics where we can send and receive information. Now, going back to what I was just saying about the speaking tubes, in the same way that we had to move your mouth to your ear, back to your mouth to your ear, rather than moving between frequencies here, we have these characteristics. One will be a read characteristic and the other one will be a write characteristic. So you send information on the write characteristic, but you read on the read characteristic. So you can also tell the Bluetooth layer that we will come to in a minute that, if a value on one of those characteristics changes, then we need to be notified about that. So let's say, for instance, your battery goes down from 99% to 98%. Well, that's new information. Let us know about that. We're not going to go down into that level of depth today, but we will at least cover the basics. So, I'm now going to switch over to a code editor, and we're going to have a look at what's actually going on here. Now, just before I do that, we're going to be running in XCode on the Mac, but, this works the same under Windows, works the same on Android. There's no real differences there. The only major thing is I have to use a mobile phone which has an actual Bluetooth antenna to talk to this, but we're not going to see the phone. So there's nothing to see on the screen there. So I'm just going to show you what's going on in the debugger window within Xcode talking to this. Okay, so I've just run up in Xcode a blank view, and I've added one line of code which is import core Bluetooth, and that's the only thing I've done so far. It appears to be working. It says it's running. I can see a blank white screen on my iPhone. So what I'm now going to do is start pulling in the information that allows us to talk to the car using Bluetooth. And you'll see how this layer sort of builds up around the car and allows us to communicate. So the first thing I've just done is added the identifiers for the Anki service and also the two characteristics that I was talking about. You can find this information online. If I just quickly run up Chrome for a second, there is, oops, wrong one, that's the Chrome web server. Okay, so there is a Drive SDK. SDK stands for Software Development Kit. It's available on GitHub. You can see up here the link to where it is. The UUIDs are actually in here. So if we go under source, vehicle GAT profile, let's have a look here. Yeah, here we go. So inside the source, there is a file called vehicle.gatprofile.h. And so I've taken those three values. It's this one here, and this one here. So yeah, that's where that information came from. So what I've now just done is added on lines 14 and 15 here the central manager, which is a core Bluetooth central manager, and basically this is responsible for just dealing with all of the underlying stuff that Bluetooth requires. And then we have another variable is called car peripheral, and this is of type core Bluetooth peripheral. So the way this works is, we've got the central manager is watching over all the Bluetooth stuff, and this car peripheral, which is of type core Bluetooth peripheral, that is going to be what we speak to. The next thing we're going to do is, because this controller, or screen if you're not a programmer, this screen is going to be the object that watches over the core Bluetooth central manager. I'm just going to add this line here that says, we are going to conform to the delegate protocol, and already now it's complaining, going, hang on a minute, how can you be the delegate if you don't have all the methods and things that we require in order to be the delegate? So what we're going to do is now put that into place. So it's asking if we want to add the stubs, so I'm just going to say yes, we're going to fix that. So what it's just done is it added here a piece of code, and I'm going to move this piece of code to the bottom because that just looks silly having it up there. So what's going to happen here is when our central manager, when our central manager changes between, say, powered on or powered off, or it's reset, it will call this function here, central manager did update state, and it will pass in information about what that new state is. I've just added in the code to handle the various states. So the states are unknown, resetting, unsupported, unauthorized, powered off, and powered on. So having created this function here, central manager did update state, we actually need to be able to call it. And the way that we're going to do that is when the view did load, after it's done its initial view loading stuff with its superclass, which is a whole other conversation for another day, we're going to add in this one line of code that says the central manager equals a new central manager, and the delegate is going to be this class, and there's no other queues or anything else that we have to worry about. So this class here, view controller, this is conforming to the protocol central manager delegate, and so yeah, that's what we're setting here, like the delegate equals self. Once this central manager starts changing state, it will call this function in this view controller as opposed to any other view controller. So let's run this up and have a look to make sure that this works. Just going to turn on that little panel at the bottom there so we can see it. So this should say powered on. There it goes. Okay, so central state is .powered on, which is this here. So we know that this got created and it called this function, and when we did a switch on there to find out which one it was, it ran this code down here. So everything's working according to plan. Okay, so what we're now going to do is I'm going to add one more line here that once the central manager has gone into the powered on state and we've seen that it's powered on, we're now going to call the scan for peripherals function, and we're going to tell it we're looking for anything that has the service here. So this Anki string service UUID, which is this up here, which is this value. And if you remember when we were looking at the SDK, they had the value labeled there, so we know what it is that we're looking for. We're looking for a car or a peripheral that has this service. This is like we're looking for the man in the photograph in 1903 earlier, but the one that's sitting down at the desk. That's the one that we're looking for. So I'm now going to run this again. Okay, and there's absolutely no complaining from the system. So that's good. Now what's happening is this is actually working. It's looking for peripherals, but there's no function at the moment to tell it what to do when it finds a peripheral. So we're going to add that in now. So what I've just added here is a piece of code that says, when the central manager did discover a peripheral, let's have a look at what that peripheral data is. So I'm going to rerun this. And as you can see now down at the bottom, because we told it, go look for anything that has this UUID, it found something. It called the did_discover method. So we print discovered Bluetooth peripheral, which we can see here. And then this print peripheral, we can see here, okay, there's an ID here, there's a name, there's a state that says it's disconnected. Okay, so if it's disconnected and we can see it, the first thing we need to do is connect to it. So I've just added some code here that says, okay, that peripheral, we're going to set the delegate of that peripheral to be our code file that we're in here, which is self. And then we're going to store that peripheral into car peripheral, which is what we had up here on line 17, right? That way, if we ever need to talk to this particular peripheral again, we have a handle on it that we can always come back to. The next thing we do is we tell the central manager to stop scanning, And then we tell the central manager, go and connect to this car peripheral thing that we just stored. Now, you can see again, it's complaining, saying that we can't assign the view controller, which is this file, to the type CB peripheral delegate. So if we click on here, we can say, okay, we can either add the as CB peripheral delegate. I think that's a sloppy solution. So what I'm going to do is change up here, CB peripheral delegate. Right, that should make this, yep, it's gone away. Okay, so now it's not complaining. The connect method, that's going to trigger a did connect. So in the same way we did discover, we're going to did connect in a second. So we need another piece of code underneath this. So, okay, here's the piece of code that says the central manager did connect to a peripheral. If this gets called, we can print connected to car, and then we're going to call discover services. Now you may remember, it's like, we've connected to a peripheral, we need to discover the services that are on that peripheral. When the services are discovered, it is going to call a function saying did discover services. Well, we need to add that in. So let's add that in. So now you can see here on line 67, I've added the did discover services function. And the first thing we do is we basically, make sure that there is a service there. And then for each service that we discover inside the services that it says it's found, we're going to print found service, and we're going to print the details of that service. Then what we're going to do is for each of those services, we're going to do a did discover characteristics for that service. As you can probably guess, when we call discover characteristics, when it finds a characteristic, it's going to call another function saying did discover characteristic and pass us in the details of that characteristic. So we need to add that code in as well. So if I add that there, okay. So now you can see did discover characteristics for, and then it says which service it is that it discovered the characteristics for. So again, we just check to make sure that there is actually a characteristic there. Then for each characteristic in the characteristics that it found, in there, we're going to print found characteristic and then print the details of the characteristic. So this will then be the blowpipe and the read pipe, going back to that photo where, one of those tubes you send the information with a command down, and the other tube is where the results are going to come back. So let me just run this up again now. As you can see, it's building. It says at the top, building 52 of 63. Here we go, installing to the phone. It's running. And now we should see, here we go. Right. So let's have a look at this in a bit more detail. We can see the state is powered on. We discovered the peripheral. We've printed out the details of the peripheral here. It was disconnected, so we called the connect. It then said it's connected to the car. We then did the discover services, so then we found a service, and that service, here's the details of it, and you'll notice that the UUID here matches this UUID up here. So there's the service. The characteristic, on the other hand, is this one that ends in E1. So the E1, so it found this one, which is the right characteristic. And then under here, you can see E0, which is this one here, which is the read characteristic. So, we can see, and there's a value sitting on that characteristic. But, if we wanted to read it, we can simply go, okay, this peripheral read characteristic, this is the characteristic we want, and we can read the value. So if I wanted to write to a characteristic on this peripheral, I could just go, car peripheral dot write value, specify my data here, specify which characteristic I'm sending to, and then here I can say whether I want to be notified or not after that information has gone through. So I could have it where it's like, I don't care, look, here's the information, do what you want with it. Or it could be a case of, look, here's some information, but I need you to tell me that you've dealt with this. So that gets set on that third parameter there. But literally, this is all that's going on under the hood. So when you have, for instance, a Bluetooth speaker, the first thing that happens is you connect to it. Then the next thing is, in order to use any of the services or characteristics on that device, the operating system has to do a discovery process. So you discover the services. For each service you find, you discover the characteristics. For each of those characteristics, you can either say, look, I wish to be notified if something changes on these, or you just make a note that you've seen these characteristics. You can then read and write to them, and that's literally how you send information. So hopefully now you can see that there is really no magic to this. Obviously, under the hood, there's a lot of magic going on because you've got radio waves, you've got transmitters, you've got encoding, decoding of information, but that's all hardware. At the software level, this is how Bluetooth works. So when you have, for instance, a Bluetooth speaker, you discover your services, you discover your characteristics. When you find the characteristic that has the audio characteristic, then you literally start sending information to it. Now, as an extra bit of reading, if you're interested in this, the Bluetooth organization does have all of these characteristics laid out. I can just quickly jump over there right now. So if we go to bluetooth.com, you will see here there's a specifications, and under specifications is GATT specifications. Now, GATT stands for the generic attributes, and they are basically the services that originally, there was very, very few services. There was, like, for instance, a Bluetooth headset service, there was a telephone service, a speaker service, and what's happened over time is that many more of these services have appeared, and they're all here. Now, a service such as reading and writing to a remote control car, that's fairly specific, so it's not going to appear on this list, but you will see, for instance, here's a heart rate service. So if I go into the heart rate service, we can actually then pick up the details as to how that particular service works. So if we dig down into this one, you'll see that there's the exact same terminology. You've got services and characteristics and things, and they basically explain, this is how this particular service works. This is, what you need to know about how to read and write to the characteristics of this service. As I said, actually compiling the data to send is a little bit beyond where I want to go today in this particular video, but this is how it works. So hopefully that explains everything that you need to know about how Bluetooth works. Yes, it can be complicated if you get down to the bits and bytes, especially when you've got multi-packet bytes and stuff and things don't arrive in the right order, and you have to assemble binary data sometimes back into long strings in the correct order. You can make this as difficult as you want, but I wanted to try and keep it a little bit higher level today, just to give you a rough understanding of what's going on. Okay, so let's come away from the computer again. So there you go. Hopefully that gave you a little bit of an in-depth look at what's really going on under the hood without sort of overwhelming you with too much information. As I said earlier, there are ways that we can send information and package that up. I think for the purposes of this video, that's too much information and we just don't need to go there. Right now, I just wanted to give you an idea as to, this is what it looks like, this is what's going on under the hood, and, the discovery process and everything else. So, hope you found that interesting. If you like these vlogs, thumbs up. If you don't like them, thumbs down. If you want to see more, please hit subscribe, and speak to you soon.